Brad has referred to his work with searching and the development of paper chase, and I hope to talk more about it because it was, I think, worthy of a Nobel Prize in its work giving access to the biomedical literature. But in addition to that, he, among many other highly innovative programs, he developed the MISAR program, or the Miniature Information Storage and Retrieval. It was a file storage and retrieval program that was really unique for its time and was used for big data before that phrase was in vogue, with such clinical conditions as psoriasis, the very debilitating dermatological condition, and stroke. We worked with Lou Kaplan with a stroke registry for Howard. And some of the code used in MISAR went to a former fellow of mine, John Greist, who was a co-founder of EPIC with Judy Faulkner. And so some of Howard's code, it was public domain, and Howard was extremely generous with all of the programs he did and gave them out to whoever asked. But some of that early code paved the way for the EPIC programs and Judy Faulkner's success.
It was also the basis of FileMan in the VA system, which is probably as widely used today as almost any clinical system.
I wonder if we might just say a word about, get your take on quality of computing. Both of you have programs that are still running today. Howard's, both I used this morning, paper chase and the acid base, among others. Warner's work with the medical history and family histories continue to be in our production system, and the hospital-wide computing system at the Beth Israel Deaconess still continues. What makes these programs so durable? And in your mind, what is a quality? What is quality computing?
Well, I think the main take-home is that the animal is never wrong. In other words, you watch what people do with the computing. If they press the on button and something comes up and they do something and it helps them, they come back and they use it again. If they press the on button and it doesn't help them, you may not have lost that customer permanently, but they're not near as likely to come back a second time, or as likely to come back for a while. They may come back later when someone else tells them, actually, you ought to try this again, and it does work, and this and that. But it's very important that the program help the user, that it be so easy to use that no user manual or instructions are needed. The user-friendliness of a computer program tends to be inversely proportional to the thickness of the user manual.
Or the length of the training period.
Or the length of the training period. So anytime a computer program comes with a thick user manual, or the doctors, the nurses, the medical students have to go through a training course that is put on by the manufacturer, the vendor of the program, that is computing that is not as likely to be heavily used, and therefore not as likely to be as helpful. And anybody who writes computer programs or who sells them and who views the problem as, why can't we get the nurses or the doctors to use these programs, I don't think understands the situation in the same way that Warner and I tended, and our colleagues tended to understand.
Our goal, our platonic form, so to speak, was to have every user, regardless of his or her department or function within the medical center, every user benefit from, ideally from each keystroke. And this goes back in a way to the pioneering work of Edgar Thorndike and John Watson and B.F. Skinner, the early pioneers of behaviorism, that with the paradigm that behavior is shaped by its consequences. The consequences are reinforcing, the behavior is strengthened. The consequences are not reinforcing, the behavior is extinguished. So if you press a key on the keyboard and something good happens, you're highly likely to do it again. And as we developed our computing systems at the Beth Israel Hospital and then Brigham and Women's Hospital, we worked really hard to have each of the users benefit. I remember building under Howard's direction, building program, and Gary Horowitz building programs within the clinical laboratory that helped the technologist early on doing the white blood cell counts and things before we'd even connected the laboratory to our hospital-wide system. And the same thing in admitting and registration. And it was just fun to go into these departments because the people would look up and say, thank you.
Howard, might at this point you tell us a little bit more about paper chase and maybe give us an example about how you would observe users?
Well, at the time that we started working on this, the National Library of Medicine had a Medline database, and they had a program called L-Hill, which was the software that allowed people to search this database. And L-Hill required a training program, so the search librarians would take anywhere from several days to several weeks of training in the use of L-Hill to allow them to search the Medline database. And if you were doing research and you wanted to search the bibliographic literature, in those days, you made an appointment with the search librarian. You came over to Countway Library, which was the New England Regional Library, where they had a trained L-Hill specialist, and you explained to that person what it is you were looking for. And the search librarian would develop a search strategy, feed it into the computer, and about a week later, by parcel post, came back a stack of references, either a very large or very medium size or very small, depending on what was in the literature based on the search criteria. And the librarian would go through and mark off the ones that he or she thought were the ones that would be most useful. And this was what you got. Well, I was thinking, if you're trying to do this for patient care, by a week later, I mean, that problem, it may not exist anymore. The patient may be dead. It's very hard to use this clinically. So wouldn't it be nice if you could just, search it right away? And we had a precedent for that because when I was a fellow, I collected reprints, and Warner collected reprints, and another colleague of ours, Doug Porter, collected reprints. And so by the time we all got together at the Beth Israel Hospital, we had over 10,000 reprints, and it was a little hard to find things in that collection. So one summer we asked one of the computer programs to write a little program to help us search these reprints. And then we hired high school students at minimum wage for the summer to type in the references. And we found this to be a useful thing. So I wondered whether we couldn't do this with the Medline database, which is a much larger database. And then one of the residents suggested that we put a terminal to use this in the library instead of in our offices, where we're able to now search it a little bit. And so we tried that, and people started using it. I actually thought that maybe 10 people would use it every day, because I thought somewhere in Beth Israel Hospital there would be 10 righteous people who would use a computer program that my colleagues and I had a little something to do with. But we put it in one afternoon at 4 o'clock, and by that night, many more than 10 people had used it, and the hospital became the largest user of the Medline database in the world within a year. So when you let people do things their own, any time of the day or night by themselves, no instructions needed, no user manual, they just walk up to the terminal and hopefully get what they're looking for enough the first time, they continue to come back. It turned out to be a rather popular program.
Thinking about now in current times, what you together did with the hospital-wide computing at the Beth Israel and the Brigham Women's Hospital is now putting in or creating a clinical computing system takes legions of consultants and prep time, and has a whole board certification section of the curriculum dedicated to leadership and change management. And I was wondering if you might reflect on that, on your experience doing the hospital-wide computing for Beth Israel Hospital and the Brigham and Women's Hospital, and share maybe what lessons you learned that might help people today doing similar work.
I was going to say it was so much fun because there was no analysts.
Might introduce Jean Sitko, who worked with us in those wonderful years.
Yes, it was because there was no analyst. It was one programmer. I would go to medical records and talk to the users, find out what they wanted, go back to my desk and program it, go and show it to them. And we didn't have, nothing had to be tested at that point in time. If the user wanted to change, they'd just call you and say, "Oh, can you make this program do this?" And you just change it. Now it's like, and then I left, and when I came back in the late, almost around 2000, instead of one person running medical records, there's 10 programmers for medical records, and you never talk to the users. There's a chain of, command that goes through, and everything goes to the, you can't make a single change without, going to another committee at the hospital. So, but I mean, it was so much fun. And what he was saying about the ease of using everything we programmed. If every prompt, if a user typed a question mark, it would tell you what it wanted, which was the most beautiful feature. I wish more systems had that feature, but it was always like, it was always, you could always type a question mark and tell the user, they'll type the last name first, comma, then first name. It was so much fun back then. Because you got to know the users and know what they needed, and you got the direct gratification of pleasing them. Computerizing, we weren't computerizing the medical record, but we were computerizing the way they got records and sent records and stuff like that, and where the records were in the hospital. I loved it.
We invited Paul Lawrence, who's professor of organizational behavior at Harvard Business School, to come over and assess our situation. And because we were doing hospital-wide integrated clinical computing in both Brigham and Women's and Beth Israel Hospital. And Paul was very reinforcing. He said what we had developed was what he called flat management. In other words, eliminating the hierarchical approach, so the person actually doing the program never met the user. And we had Jean working directly with the users, and it was much more reinforcing for her because the users were appreciative. Right. And we found that committees with developing specifications for systems in advance were really not all that helpful. I remember when we did the bacteriology system at the Beth Israel Hospital. Before we were invited to do that, there had been probably a year's worth of committee meetings with all these specs, which we found of no help whatsoever. We went down to Geronimus, who ran the lab, and found out what he needed and proceeded to develop it. And it was a wonderful experience because Jean, you would be working with the user, and then she would say, "I know this is what I told you, but what I really wanted was something that looked more like this," and so forth. So could it be immediate adjustment to the system and be home together in a partnership.
Right.
I might also say that one of our premises has been back to computer interviewing of patients, has been that the largest, least well-utilized healthcare resource worldwide has been the patient or prospective patient, and that the interactive computing computer could be helpful to patients. My idea back in the 60s was that we should work to enable patients to participate with their clinicians in medical decisions, and that the traditional paternalism in Western medicine was actually hindering a badness as far as the quality of care. And in the vernacular of times, and this was at the University of Wisconsin, which was a wonderfully sort of radical environment, I called this patient power. And it was quite controversial at the time, but and it was interesting that the computer enabled me to implement the ideas of patient power outside of the traditional clinical transaction. For example, I thought that in a medical history there ought to be the equivalent of a Fifth Amendment provision. If a person didn't want to answer a question, we tend to assume that it's patient's responsibility. So I put a none of your damn business option in there. Now, I had to tone that down to skip it, or rather not answer here in Boston, a far more conservative community. And then in student health at the University of Wisconsin, we were very eager to establish good rapport. So with the students, as they start, are you a student here at the University of Wisconsin? This was in the 60s now. And the student pressed yes. The computer offered right on, power to the people, free Angela Davis. Immediately, there was good rapport.
So now we have computers in about every hospital room and about every examination room or clinical office. So I want to ask sort of the other vector, which is the computer now being a permanent part of the picture, is it eroding some of the patient and doctor relationship? And if so, what could we do about it?
Well, it saddens me when I hear a hardworking primary care doctor say, you know, I love getting the results of diagnostic studies back, but the computer is demanding so much of me. I have to spend so much time entering the information and so forth. That Lud Gutman, a classmate of mine in medical school, was the chairman of neurology at the University of West Virginia, with their computing system, said, you know, it was great to get the blood counts, but gee, Warner, why do we have to spend so much time entering information and helping the administrators? This saddens me because I think that I hope that in the future, the behavioral approach will come into being, and the hospital-wide clinical computing systems will be marketed with the promise that all users will be benefited, and that the ratio of helpfulness to arduous entry time and things will be extremely high.
Would you also reflect on what is, as computers and clinical organizations now have pathways and created order sets and sort of standardized ways of doing things, what does that do to clinician autonomy? Is it becoming too much cookbook medicine? What's the right balance of help and sort of nudging?
I think it's a judgment call. And I think the more the clinicians can have input into it, You can help people with checklists, particularly if people want them and can modify them. I think in a hospital, though, one thing that's constant and it's always changing. It's very hard to make specifications, printed specifications that can then serve as a template. I'm saddened by these committees that I hear about because I think a very important principle was one person who programs working on one area of the hospital's computing system in very close contact with the users of that software. And I also think it's a bit of a misnomer. I know people need handles, and Warner and I are often associated with various things that we may have done. But the real brains behind this was the crowdsourcing. It was the collective wisdom of all of these users. There was no way that any of us, any single individual, can possibly match that collective wisdom. Those people, as soon as, I mean, just think about it. You do a lab system and you report the laboratory results. And then it occurs to somebody, well, why don't we tell the lab technologists at noontime which laboratory values changed markedly since yesterday, because maybe they want to call those doctors and alert them before the doctors had a chance to look at the laboratory results in the computer, that this is something that needs perhaps more immediate attention. So we did that. But it didn't occur to us to do the next thing until about 3 days later. One of those technologists called us and said, I see you people have the doctor's telephone numbers in the computer. You give us the list of the abnormal results that need immediate attention. Can't you put the telephone number next to that? It never would have occurred to us, in that kind of time frame. But this was a user who saw this immediate problem because the user was faced with looking up all those telephone numbers. Well, you call the programmer. We called all of us programmers who was involved in that laboratory system. And later that afternoon, that program was calling that user back and said, take a look at the display I've now written for you and see if it does what you want. And it's that kind of suggestion that was constantly coming through. Now, medical students weren't always polite in their suggestions, but every complaint, every castigation, every condemnation was a little nugget of useful suggestion that we could use to make the programs better. And that's what made the programs better. It wasn't the committees. We didn't have committees.
The committees are a means of extinguishing these good ideas.
Exactly.
I want to ask one last question and then open it up. I want to talk about openness and sharing. And Warner, you alluded to this, but I know your goal has been to make the medical history be available to everyone. And Howard has been generous with his code. And I had heard one story where he gave the source code away and also 90 test cases to make sure that it still worked in that environment. And I wonder if you might reflect if we're as open today as you were and what your motivations were for being so open and collaborative.
Well, I think it's fair to say that we've been idealists, and I love the idea of whatever, and I was being paid well as a faculty member of the Harvard Medical School, and was able to get ideas that we had generated and tested into publication and out to the public. And I just love the idea of having these programs available to as many people as possible. I mean, I had this fantasy that what we had done to help improve the quality of medical care would be available to everybody in the world. That was a goal. And with our programs, Converse, we gave that to many people around our country and abroad, and I like to think it was helpful to them. I do want to change the post. I just want to mention that one of the high points of our division truly was when a young primary care doctor and computer scientist came to join us, Charlie Safran, who has done wonderful pioneering work. So many programs, CleanQuery comes immediately to mind, searching the database really well before its time, and is now our division chief. So I just wanted to thank Charlie for all of his wonderful work. And I might mention, in conjunction with a hospital-wide system, Bob Beckley, who came to us from Meditech with Howard, brought to us an electronic mail system that we put up at the Beth Israel Hospital. And I do think it was the first email system in any clinical facility in the country. And I can remember administrators, they would change with time, but coming and decrying the fact that people were using email for personal messages. And I can remember saying, John, do you want the programmer to leave her station and walk all the way across the medical center to invite somebody to lunch when she could do it in a few seconds? Oh, Slack, okay, you know. So, with that way. And one of the features that we built into our email system was, inquire if the message had been read, which was very helpful. And then retract the message with something that's not still available out with the internet. And with retract the message, you could experience the psychological benefit of a verbal catharsis. But then, if it hadn't been read, pull it back. And the neurologist in me was playing with the idea of how to retract it after it had been read. Fortunately, totally unsuccessful.
Did you ever use that for practice? You never used it, right?
I'm not sure I just did, but people like to have.
He didn't need it. I used it.
I think I did.
If I may open it up to the floor. Or anybody on the phone.
I just was wondering, from your perspective, since you saw those tools coming from birth to where we are today, did we make as much progress as you were hoping, and especially the places where we didn't, if you have thoughts on why?
I think the biggest inhibitor of progress is the fabrication costs, you know, the packaging, the feeling that things need to be done by consensus, as opposed to trying things out. It's so much more efficient to try something out, and if it doesn't work, to fix it, than it is to plan it ahead of time and think you can get it right. I think the concept of central planning in computing, however wonderful it is and everything else, doesn't work very well. There's none of us who's smart enough to know what it is. Even the user will often come to the program, and I think Jean can tell us this better than I can, and say, could you do this for me? And as soon as the programmer does it and takes it back to the user, the user looks at it and says, okay, now that I see what you've done, I now see a better way to do it, or I now see what I really want, and so forth. It reminds you of the surgeon that says to the, screams at the nurse, don't hand me what I asked for, hand me what I need. You know, and often the programmer would take what a user would say and realize even before the user did that there's even a better way to do it. And, you know, and add another thing to it that would make it even better and so on.
One of the things with VIX, when you stopped running VIX, or when it became VIX, I don't think it was called VIX before that, but we worked for you, everyone used very strict conventions of programming, form driver, file structure. We all knew what the file structure should look like. We all knew which file to use. We used the same file. And then when people start interfering with that, they start hiring people that didn't have your training. They're doing it different ways. And that's why it ended up with 10 programmers to maintain, because after 30 years, it's spaghetti. It's got, people are making changes and they're using all different conventions. So you can't count on them. Everything becomes very difficult to do because the conventions we had used, which we were fairly strict in filing things and file structure, that was that led to the demise of VIX. Had it been able to be maintained by one programmer, I think they would still be using it. I think it just got too many people needed to maintain it because there was such spaghetti code.
That's so well said, Gene. And there are natural forces. C. Northcote Parkinson, great English economist, developed the law of growth independent of function. And he pointed out that in an administrative hierarchy, the administrator hires two subordinates, not peers, because that, and not just one subordinate, because that's an unstable dyad. But having two people under you creates stability, and they in turn want to have two people under them. And there's this growth independent of function, and he applied it to the British Colonial Office, and as the number of colonies was going down, the growth of the administrators in the Colonial Office was going up by his constant. Same thing with the Naval Department. As the number of ships were being dry docked and put away after the Second World War, the number of administrators within the Naval Department went up by the Parkinson constant. And I have a law of committees. Why there are so many committees may not be intuitively obvious, but it's because it's more prestigious to form one than to be on one. Like Her Majesty's ship that she never goes on board, or the Dean's Committee on Analytic Engines, which he appears briefly and said this committee is really important and then leaves. But if you are if you have to be there, then you want to be chair. And if you're chair, the best thing to do is to form two subcommittees. And sort of a parallel to Parkinson's law, and then they in turn form two subcommittees, and it goes that way. So, and hospitals are very complex. I love the marketplace forces that are so helpful. I mean, with regard to iPhones and things, there's really competition that is creating better and better devices. I would love to see those forces apply to hospital information systems, if possible, where people were marketing them on the basis of how helpful they were to all of the users.
Charlie?
Well, time's late, and it's been wonderful to hear you talk about some of the work that you've done. I wonder, maybe as sort of a final comment, maybe you might speculate. One of the issues that we all grapple with is getting to scale on a national level, whether you're a country that has 6 million people like the state of Massachusetts, or a country like ours that has 300 million. And I know it's the belief of almost every expert that we ever have come talk to us that somehow computers are going to solve the costs of healthcare and the quality issues in healthcare and the others. So we hear that at the end of every lecture. And so my question really is not so much how to get to scale, but is there a role for government in this process, or are they part of the problem as you see it? How is it that, at least we've talked about sort of the hospital level, but I'm sort of wondering about what role people that have money, which are, maybe it's the government, but they do spend a couple $1 trillion on healthcare. What are your thoughts about that?
One of the first thoughts that comes to my mind is a negative, that when I and my colleagues were arguing for patient power, I was also arguing for declassifying the medical chart, opening the chart and even suggesting that the patient should play a role in the development of the chart. That was considered very radical. And we worked hard on ways to protect confidentiality. But the government, well, in many ways well-meaning, has initiated all sorts of rules and regulations about making the chart available and so forth. That actually it's an example of overreach. I think there are a number of things that could be done in medicine and with computing in medicine that could be done just because they are good, and there's a general agreement that this is worthwhile, that the chart should be available to the patient. And I think there was any regulation that needed to be passed. Thomas Jefferson once pointed out that when you pass a law to solve one problem, you often create two in its place. And I think we're all aware of the HIPAA overreach that is in many respects hindering or impeding the progress towards good medicine.
Howard, any final comments?
I think if I had to summarize what success, if any, Warner and I had, it would be, we tried to decide a little bit about what needed to be done, and then we surrounded ourselves with people who could do it better than we could. And then we try to treat the people as good as we could, because the most important asset you have in trying to do computing, medical computing, any kind, is the people. You can replace the wires and the computers, and you can always, that is not near as important as the quality, the kind of people you have. And if you can get good people and try to treat them well, if that becomes the thing you're most proud of when you, at the end of the day, when it's time to retire and you step back and you say, what is it you did that you're most proud of? I think in our case, it would hopefully be the way we at least try to treat our people fairly. The programmers, the operations people, everybody, our colleagues that we work with.
And to have Gene Sitko come here today and look back with fond memories over that
They
period
were
of time.
wonderful to work for.
That totally makes my day.
Well, thank you both so much. This was a wonderful session to talk about some of the lessons you've learned, and I've learned so much from both of you, and I hope that this has been useful to our audience as well. So thank you again.
Thank you.